Hello and welcome to tonight's Commonwealth Club World Affairs program. So tonight we're going to talk about the science of Project Hail Mary. And that's hosted in partnership between Wonderfest and the SETI Institute. And I'm going to be very good. There are people we know quite famously who go off script. I'm not going to do that. So I will be reading from my script just to make sure we don't miss anything out. So a few reminders before we get started. The first is tonight's program is being recorded. So we kindly ask that you silence your phones, put them on mute and or vibrate for the duration of the program. Also, if you have any questions for our guest speakers, you'll see cards that you can fill in. And you can put your questions on the cards. They are on your seats. Or you can put them in the chat on YouTube. So Andy Weir, the author of The Martian, appears to have another home run on his hands with his latest book and now a major motion picture, Project Hail Mary. So tonight, our speakers and hosts are going to dig into the science and technology behind the story. So it's my distinct pleasure to introduce tonight's panelists, Dr. Maggie Turnbull, Dr. Pascal Lee, and Tucker Hyatt. Dr. Maggie Turnbull is an astrobiologist at the SETI Institute, and she specializes in identifying planetary systems that are capable of supporting life as we know it, so-called habitable environments. She developed a catalog of habitable stellar systems for use in the search for extraterrestrial intelligence and has studied the spectrum of Earth to identify telltale signatures of life. Maggie also led the exoplanet science team for the Nancy Grace Roman coronagraphic imaging camera, which will launch this fall and take the first pictures of exoplanets in a mature solar system like our own, our own sun solar system. Dr. Pascal Lee is a planetary scientist at the SETI Institute. He's also chairman of the Mars Institute, director of the NASA Hot on Mars project at NASA Ames Research Center and the SETI Institute in Mountain View, California. His research focuses on the history of water on Mars and on planning future exploration, human exploration of Mars and the Moon. Dr. Lee has led over 30 expeditions to the Arctic and Antarctica to study Mars by comparison with Earth, so-called analog research studies. He also studies asteroids, the two moons of Mars, and lunar features such as lava tubes and so-called permanently shadowed regions. Moderating tonight's program is Tucker Hyatt. He's the founding director of Wonderfest, the San Francisco Bay Area beacon of science. Tucker has also taught physics at numerous academic institutions and was a visiting scholar at Stanford University in the chemistry department from 2008 to 2014. So please welcome tonight's host and our panelists. Thank you very much.
I want to thank Bill Diamond for giving me what I assume was a kind introduction. I'm grateful, Bill, and I'm very happy to be here tonight, this afternoon, welcoming you to a discussion with Dr. Maggie Turnbull and Dr. Pascal Lee of this great book by Andy Weir, Project Hail Mary, which has been adopted into a spectacular movie starring Ryan Gosling as molecular biologist Dr. Ryland Grace. RG, Ryan Gosling, is portraying RG, Ryland Grace. Amazing, amazing, amazing. Before we get started with the questions here, I'd like to ask how many people are in the audience have read the book, Project Hail Mary? Impressive. Mm-hmm. How about how many have seen the movie? All right. Yep. Your questions are going to be tough. I know it. This is serious. Let's start with a question for both our speakers. I want to welcome Dr. Turnbull and Dr. Lee. Let me ask, from a scientific point of view, your scientific points of view, what did you think of the Project Hail Mary book and or movie?
Well, I had a lot of questions about the science, but I will say I loved the story. I loved the story because of the friendship that developed, between the two of them, and just the poignancy of having to leave home for both of them, but especially for RG, who didn't get to go back, and But it was forging that new friendship that I think was the most meaningful for me personally.
the connections that you have emphasized at another presentation recently. Beautiful.
Yeah, I enjoyed the book and the movie. I thought the movie was very well done. It stuck pretty closely to the book. Scientifically, there are. First of all, I happen to know Andy Weir. He used to live in Mountain View, and in fact is one of on the board of advisors, I think, of the SETI Institute still. But he's aware that he took some liberties on the physics, on the chemistry, on the biology. So those are not mistakes. Those are just liberties that he took. So given that, I think overall the book is very interesting scientifically. It's very exciting because it really gives you food for thought on what's possible and what isn't. It brings together all kinds of corners of science, biology, physics, and then the film. I thought the film was a nice interstellar bromance. So, yeah.
Every good, or most good stories need a villain. And the villain in this story, it also turned out to be a helper, is this microbe called astrophage. By the way, this presentation is full of spoilers, but I'm sorry, it's got to be there. Astrophage, what do you think the odds are of astrophage evolving, originating and evolving here in this galaxy?
0. I don't know.
It's got
Maybe
some
you're more
remarkable
imaginative
properties.
than I am.
Well, that's one of the liberties he took. So the astrophage, the way it works, it's feeding on the star,
Yes.
right? And it absorbs the energy, but instead of allowing the star's energy to sort of destroy it, because we're in a 5,000 degree or up to millions of degrees in the corona, but we're in a plasma essentially. But instead of allowing that to destroy you, the bacterium automatically converts that into neutrinos, so stored energy, and so therefore it retains a relatively constant temperature on the inside that's pleasant for it. So that goes against several laws of physics. But okay, be that as it may, let's say that were possible, and so then the rest sort of unfolds pretty consistently with those assumptions.
Yeah, I was thinking about this for a few times in the shower, actually. Like, how could this possibly happen? And I was just imagining, maybe not storing neutrinos, but some other way of, like, you get all this radiation coming in, all this energy, it has to go somewhere. Like, it has to go somewhere. It can't just get infinitely forever trapped in these little opaque creatures. And unless there's something going on inside of them that is being reconfigured and somehow physically storing that energy in a different way so that it can then be liberated. But I was just kind of like, no, this is too mind-altering for me. But I mean, it was a cool idea, though.
Yeah. I mean, what's interesting, too, is this concept that life form originated, you find out at the end, it actually originated sort of around one star, but then spread to others. And so there's this concept that's, well known, often talked about, called panspermia, where you start life somewhere and then it ends up seeding its local galactic neighborhood. That's I think an interesting take on that panspermia concept. And it's one thing to worry about whether or not it could survive on the surface of the sun, but it's also intriguing to think that a life form could migrate from star system to star system and be able to survive that journey somehow.
Yeah, usually we think of panspermia as hitching a ride on a rock that got ejected from an impact or some kind of close encounter that threw it off into space. But these little guys are just going by their own propulsion at nearly the speed of light.
Yeah.
And all the stellar systems in the local neighborhood, all the stars are infected except Tau Ceti, which gives humanity hope. Hence the voyage to Tau Ceti. But I understand, Dr. Turnbull, that you know something about Tau Ceti. You have some inside scoop on it. Can you tell us about that?
Right. Well, there's actually a whole ecosystem of just kidding. In the book, in the book, there's a whole ecosystem that's keeping them in balance, right? So they're not destroying their star. But Tau Ceti is on the list. It's on the list of interesting stars to look for life, and also for habitable planets. And I said those separately because they're kind of, on the one hand, we have SETI searches, where Tau Ceti potentially emerges as an interesting target, just being so nearby and relatively sun-like, is fainter than the sun. It may have planets around it. There are unconfirmed possible planet detections around of super Earths. But actually, I think more interesting to me is the direct imaging searches that we might want to do. That is a very good candidate. It's so nearby. The habitable zone would be big enough, just because it's so nearby, to be able to actually take pictures and directly image any planets that might be there and just find out if they're real.
The habitable zone refers to the part of the solar system where water could exist on a world in a liquid form?
That's right. So Tau Ceti being fainter than the sun, significantly fainter than the sun, its habitable zone would be closer in, about at the separation where Venus is from our sun. So because the star is fainter. But the system is so close to us that still would be angularly large enough for us to get into with the best cameras that we could imagine building. There are other issues with that system or interesting things about that system, like it has a massively huge debris field out, like our Kuiper belt, more massive than that. That actually has been imaged already, so we know that's there. And it's strange to me because that star is actually very low metallicity, meaning it doesn't have very much iron or heavy elements, which raises a question for me about what all that stuff is made of. I mean, I guess it's ices and volatiles, but could there be terrestrial planets around it without so many heavy elements, or is that fine? The planets that might be there are thought to be like super Earth size, so they would be in the range of a terrestrial planet, type of planet.
The habitable zone for our sun covers certainly Earth, Mars as well. And does it go out? What is the habitable zone for the sun?
Mars is just on the outer edge of it. The Earth is inside the inner edge.
Okay.
But Mars is just on the outer edge. So, liquid water is not really possible in just pure form at the surface of Mars today. But we still think there could be liquid brines, so very salty and not table salt brines with a compound called perchlorate. And perchlorates are rampant on Mars, but they lower the freezing point of water to minus 70 degrees C if they are at the right concentration. So you could have essentially salt water running at the surface of Mars even today, but it's not pure water, it's a sludge.
And yet, is it true that searches for life in our solar system go beyond Mars, including what isn't in the habitable zone, say the moons of Jupiter, Enceladus, and Europa?
Mm-hmm.
And they're
Yeah.
Yeah, I mean, we have like the circumstellar habitable zone, which the Earth is in, kind of close to the inner edge, alarmingly, but it is in the circumstellar habitable zone. And then you could imagine a circumgiant planetary habitable zone where the moons are getting enough tidal forces from interacting with each other and being on these fairly tight orbits around the giant planet that heats up those moons enough that inside they could have liquid water oceans like Europa, other moons in the solar system.
Mm-hmm. There's also the concept of a galactic habitable zone, because the center of our galaxy has so many stars that many stars die, and so you have a lot of exposure of your planets in the inner zone of the galaxy to gamma ray bursts, which would wipe out life at the very surface of planets.
From the center of the galaxy?
From stars that are dying, but they're in such close proximity to one another. I mean, still interstellar distances, but in a relative sense. And so the thinking is that the chances of a life form being able to thrive at the surface of a planet that's near the center of its galaxy are actually lower than on the outer edges, which is where we are.
Yeah.
Middle to outer edges.
I think there's a slight metallicity gradient too throughout the galaxy.
Yep.
So you have more metals to work with near the center of the galaxy, but you have, like you were saying, more, it's a higher energy radiation environment. And then you could imagine this sweet spot in the galaxy where you've got stars that have the right amount of metallicity, maybe they're not encountering each other too much. They're not passing in and out of spiral arms all the time,
Yep.
And it's just kind of peaceful. But then you get way out into the burbs, and maybe there's actually not enough material to work with out there. So you could sort of imagine kind of this habitable area around the galaxy. And then even in star clusters, you've got maybe some regions where there are more stars and a civilization could get between the stars, like more easily.
We're going to call that the galactic Goldilocks zone. So
Yeah.
GG.
Yeah. There's good neighborhoods.
In Project Hail Mary, having seen that Tau Ceti is not infected with astrophage, humanity builds a starship, the Hail Mary's name, with Hail Mary's name. And I think some of us are curious about the feasibility, even given the enormous advantage of propulsion via astrophage, about getting from the solar system to a destination, 12 light years away.
Yep.
To investigate Tau Ceti properly, you gotta go there, I guess, to find out why astrophage hasn't found a way to eat that star. So what do you think about the Hail Mary as a starship? Do you think we'll ever go 12 light years?
Well, I know I gave you my initial take on this when we chatted last week, which was this sending human bodies. We're intimately designed to live on this planet. I mean, we really are. And to ship a human body across space and go somewhere else is so problematic and seems like there has to be a better way, on the other hand, I was reflecting on Carl Sagan's words recently, or just actually today, about future generations. That effort of having that goal to actually travel between the stars, that is it's transformational, psychologically transformational for us to even make an effort like that. So the future generations that might be able to do something like that will be different. They will have different psychological qualities to them that make this maybe more feasible. But just in terms of the straight up biology, I feel confused, like how this could
Yeah, to me, the interstellar travel part of the book and the movie were sort of the most interesting aspects. And I think everybody has to sort of realize the daunting scale of all these things. If I often explain that if the sun were the size of a grapefruit, and you put it in San Francisco at the beginning of the Golden Gate Bridge, Pluto would be a tiny little, smaller than even a pinhead, at the distance of the first pillar. Okay. And the nearest star to the sun, Proxima Centauri, is a little red dwarf, so it's about the size of a cherry at that scale. It's in Chicago. In this book and movie, Tau Ceti is 12 light years away instead of 4.26 for Proxima Centauri. So Tau Ceti is in Cairo relative to the grapefruit in San Francisco. And 40 Eridani, which is where Rocky comes from, That is in Hong Kong, so 11,000 kilometers away from San Francisco.
Yeah.
But I want to see Egypt. I want to see Hong Kong.
You don't want to see, yeah, so exactly. So it's a slow boat to China. But,
Wow.
Oh.
but here's the thing, so first of all, classically, right, the interstellar travel is conceived as either hibernation, which is sort of what was done here, except that instead of hibernating, the guy's in an induced coma, or you have what you call the generational starships, where the first generation of migrants leaves the Earth, but then it's only several generations later that one lucky generation will reach the destination. And then in the meantime, you have generations of humans on board the ship who are just living in the middle of nowhere.
Who curse their ancestors and curse their descendants.
Yeah.
Or when they get there, they're so familiar with the ship that they don't want to get
Oh,
off. They're
yeah, that's
fine.
home.
They're fine. Why did we come here? We're good.
But to me, the solution to this is sort of emerging today with android robots and artificial general intelligence and eventually artificial superintelligence. We no longer have to travel as biological humans. We can just travel with our DNA and whatever else it takes to clone us on the far end. And we can just travel with android robots as our keepers. And of course, those require much less power, no life support. All of a sudden, I see the possibility of interstellar travel becoming tangibly possible.
Wow.
Yeah.
I love the fact that this fantastic energy source has made, in Project Hail Mary, interstellar travel possible. That Ryland Grace can take a trip that humans measure as being 12 light years distance. He sees it as roughly a 4 light year distance, because relative to him, in the Hail Mary, space contracts. Relativity does tell us this, and it's been confirmed not with spacecraft, but millions of times with fundamental particles. Length contraction happens, and so those distances, those incredible interstellar distances, become shrunk when you're in a spacecraft that, relative to those distances, is moving quickly. So we got to get something, but the energy, yeah, that is really a rough point.
Yep.
I was struck by Rocky's crew being surprised that they got to their destination quicker than they were expecting. And I thought, maybe you can comment on this. I actually didn't have time to look into this, but I thought that relativistic effects were not totally insignificant even for us trying to land something on Mars. Like, we really have to, we can't just not account for relativity.
That's interesting, because we have atomic clocks that are essentially timing signals, and we take into account relativistic distortions. But yeah, in the case of the time travel, the premise here is what's known as the Langevin paradox, named after Paul Langevin, who was Marie Curie's lover after Pierre Curie died, and may possibly before Pierre Curie died as well. But anyway, Paul Langevin came up with the twin paradox, which is this notion that if you have twins, and one stays on the Earth, and in other words, does not change frame of reference, that's sort of the most important thing, and the other one travels at a range of speeds that are different from what is happening at the original frame of reference, then the clock starts ticking more slowly on board. And that results, if you're flying close enough to the speed of light, it results in a tangible, significant shrinkage of time. So there you have it.
Yeah, sweet.
So even though the star is 12 light years away, it takes Ryland Grace only about 3 to 4 years to get there, and there you have it.
Is that actually true, that we do need to account for relativistic effects when we're going to the other planets, even within our own solar system?
I've heard of that, but I'm not.
I would have thought
on the
Rocky's people
details.
would have noticed this, like on smaller scales.
I think the premise they have is that they don't know anything about relativity or even radiation, as far as I
Yeah.
if I remember. Which is a bit surprising if they can have a big starship like that.
I know. Yeah, they really accomplish a lot without knowing these things. And
Crucial to Ryland's successful transport for this long a time was him being put in an induced medical coma at the start. And his other two shipmates didn't make it. You have any sense about whether that kind of aid to transport is feasible?
I asked my brother, who's here tonight. He's a neurosurgeon at Stanford. Anyway, he was shaking his head when we saw that, because comas are apparently pretty dangerous, and putting somebody in an induced coma for 4 years, they're more likely not to wake up than to survive that. But I guess the concern in the book was that otherwise they were going to lock up 3 people who were in a very tight space on a one-way trip, a suicide mission, and they thought that they would end up killing themselves
Or each
sooner.
other.
yeah.
So that's why
Their minds.
Andy came up with this induced coma thing. But
Yeah.
I guess there have been instances of people being in comas that were not intentionally
Yeah.
induced and waking
Yeah.
up from them eventually. So it must be possible. But whether we know how to do that on
Yeah.
purpose.
I talked to an expert anesthesiologist who said he was quite impressed by Andy Weir's including in the book the fact that people vary considerably in their ability to exist, to survive comas. And there is a genetic factor, and that this specialist said that the fact that Andy Weir knew that and included it in the book was another tribute to the quality of his science writing. Let me ask about another planet, another star rather, besides Tau Ceti that was important to this novel, and that is 40 Eridani, where apparently on a planet orbiting 40 Eridani, life evolved with the key solvent not being water, but being ammonia. Does that strike you as something? Are there other ways that life can survive besides needing water?
Well, would it be okay if I said something about 40 Eridani really quick? Because it's an interesting system. It's a triple system.
Yeah.
And, the main star that he's presumably from, star A, is, again, it's cooler than the sun, fainter than the sun. Habzone is closer, similar actually to Tau Ceti in that way. And also lower metallicity, so could you have planets? I don't know. Yeah. But the pair that's orbiting a few hundred AU away is a red dwarf star, so a lot smaller, kind of just bigger than Jupiter, really, but a star, and a white dwarf, which, if anybody in here knows about white dwarfs, that's bad news. If you have a white dwarf, that means you used to have a massive star that blew up in the system.
Yeah.
And the whole system would have been really impacted by that. So anyway, I just thought I would throw that out.
Yeah, that's the fate of the sun, to become a white dwarf.
Eventually, yeah. So then first you become a red giant and engulf all the planets and throw off all this stuff. And so it went through, that system has seen some things.
Cool.
But first of all, it's like in Seinfeld, the worlds of George collide, because 40 Eridani's main star, which is 40 Eridani A, is supposed to have planet Vulcan around it. That's where Mr.
right.
Spock is from.
That's right.
And so that went out the window when it became Rocky's home.
Right. Yeah, we got a conflict here. We got to resolve this somehow.
Yes, worlds collide. You should have picked another star.
Wow.
And there is a candidate planet, Vulcan, for real, around that star, but it has not been confirmed.
Right,
so,
that's right.
We have multiple layers of intrigue here with that putative planet.
We're going to learn more about this from you, not tonight, but in the press, right? This is important stuff. All right, I'm going to count it from the SETI Institute. How about this calls on your expertise in psychology and linguistics. How do you feel about the odds of that communication during first contact? if first contact happens, I thought Andy Weir did a great job of describing the process, at least a conceivable process, of making communication happen so that they could accomplish saving humanity, for Pete's sake. But what do you think? Would it take years and dozens of experts?
Wow, it's a great question.
You know, I mean, my guess is that there would obviously be a huge communication barrier, but at the same time, there's a common language, which is science and mathematics. And I think to that extent, that's probably, and of course, you're encountering an alien, not, an octopus. I think they would probably understand what it would take to understand each other eventually, maybe by signs and gestures and representations of things. But yeah, it's a challenge. And in particular, Rocky, right, doesn't actually have eyes. I think he's like bats have eyes, but they use sonar, and he's using essentially sonar, echo
Yes.
Mapping.
mapping to perceive his surroundings, which incidentally is a flaw in the movie because Rocky's also watching the computer screen of Rylan, his laptop. But anyway.
Yeah, no, but that was, I loved that Rocky spoke in musical chords, and that was his, these like complicated musical phrases were his way of communicating. And of course, Ryland Grace had a code and a computer that could eventually like recognize all of that. And but I think about the animals on planet Earth and their communications with one another using musical, what is along the lines of musical phrases and stuff, and we have no idea what they're saying to each other. I think we have a scientist at the SETI Institute, Lawrence Doyle, who did an analysis of dolphin communications and just looking at the sounds and could mathematically tell that when little dolphin, I think it was dolphins or porpoises, it was one of the ocean mammals that talks to each other that way, that when the little ones are born, they follow a similar evolution to humans, where they're just babbling and making babble sounds, and then they start mimicking and copying and using very simple little phrases that the adults use, and then they eventually start communicating in more complex ways. But we still, we can recognize that happening, which I think is wonderful. But we still have no idea. We don't know what they're saying. Which, why not? Why haven't we figured out what the dolphins are saying to each other? So that might cast a little doubt on how well we would do with an alien species.
I don't remember in the novel there being any direct reference to a great science fiction work earlier in this realm, and that was Close Encounters of the Third Kind. But in seeing the movie just yesterday, I was struck by the reference tones used in Close Encounters came back to life. At least we heard them in Hail Mary. Yeah,
That was nice.
that was
Yeah.
very nice. Do you think that there are other key movies, key novels, motion pictures that will be that we can remember that were so influential that they will affect us the way Close Encounters did? I'm thinking my own life. I remember seeing 2001: A Space Odyssey, and I just wonder, it is when it first came out, and it got to me deeply, and I just wonder, could this movie, Project Hail Mary, could that possibly affect today's youth, today's folks like us, in the way that those early impressive films and books about SETI did? Think it's feasible?
Well, I think that in spite of the scientific liberties that Andy took, this book and movie actually sort of celebrate science. They celebrate scientists. This Ryland Grace is scientist turned school teacher and gets brought back into the fold of doing science again. I like this whole atmosphere that is conveyed by the book, and I think in that sense it can trigger lots of passions for science and interest in being a scientist. I thought it was pretty powerful in that sense, and you don't quite get that from 2001: A Space Odyssey. On the other hand, 2001: A Space Odyssey is still up there because it's such a grand vision of things.
You know, I thought of the movie E.T. a couple times
Yeah.
when watching it. And, you know, that made a huge impact on a lot of young people, I think, you know, being so friendly and accessible. And Rocky's character had some similarities to E.T.
Yep,
in some
yep,
ways.
Good.
Yep. Tucker?
Oh,
And I
Thank
think,
you.
like, you know, coming back to this friendship, you know, the idea of friendship and the portrayal of an alien species and that encounter as a benign, collaborative, well-intended
Yep.
type of
That
thing.
was nice.
Yeah.
Very well done.
are you ready for some questions from our audience? Here we go.
Sure.
If we humans on Earth actually did detect something dimming a star as astrophage does, what would scientists do first?
I mean, we obviously have to try to understand why, right, and come up with hypotheses. But astrophage would not be a leading hypothesis.
No. We would continue monitoring it for
Yeah.
several decades to see what happens and show that there really is something happening. It takes a long time with stars. Stars live for billions of years. You don't just sort of notice one day that it's dimmer this year than it was a year ago. You kind of just note the change and keep observing.
I got to say, as having been a science teacher myself for 33 years, I was really touched by the depth of Ryan Grace's pain when thinking about how his students would fare when the cold set in. And in this case, I wondered, do you think he was also Andy Weir was making a comment about global warming? Although it's a reverse effect, worrying about climate change is something that might, do you think, have been snuck into Project Hail Mary?
I've actually heard Andy's view on global warming. I mean, he obviously thinks it's a real phenomenon, but his take on it is that ultimately what's going to happen is, because we don't have a global government, we'll just have to take palliative measures as opposed to fixing the root cause. Mm-hmm. You know, so if the sea level rises, well then, you know, you won't be able to build houses that close to the edge of the coast anymore. You know, I think his other example was polar bears. Okay, we'll just have to protect them or let them go. In other words, we'll just have to live with it, as opposed to, that's his practical thought on what happens if we have what our future holds in terms of what's happening with global warming. Yeah. Mm-hmm. But anyway.
So instead of the old admonition to go west, young person, it'll be go uphill, young person. Yeah.
Go uphill,
Basically, you know, I mean, it's going to be about mitigation. I mean, even at this point, if we were able to just stop CO2 emissions instantly, that would not be good enough to avoid some serious consequences coming down the pipeline at this point. But it does kind of, I guess it raises a question for me, you know, about the future. Even the people who are young right now, the people who are kids right now, you know, we think about, you know, I've got a couple nieces and a nephew who are around the age of 10, plus or minus a few years. And I do wonder what their lives are going to be like, you know, when they get to be my age and beyond. And if they have kids, you know, what that's going to be like for them. So I think, you know, my parents, who are the grandparents of these kids, I wonder how they feel about that, you know, having when they were kids, this was not really a thing that was being talked about. And now today's kids have just a whole different slew of things to be concerned about. And we don't really know how to prepare them other than to say, yeah, try to find some high ground. Doesn't feel right. It doesn't feel sufficient, you know.
And you know, there's a lot of misinformation about climate change and global warming. I was having this discussion the other day, and the comment was, well, you know, in the Jurassic, the temperature on Earth was several degrees, if not up to 14 degrees warmer than on the Earth. There have been periods in geologic history where the global average temperature of the Earth was significantly higher than today. Okay, but I think they're missing the point. The point is not that the temperature is increasing, it's the rate at which it's increasing. And there has been no period in Earth's history where the rate of temperature increase has been as steep as now. And that clearly makes it attributable to human activities. So if we create it, we ought to be able to do something about it.
I want to commend this audience on its penmanship. They say this is really impressive, beautiful handwriting. Dr. Turnbull and Dr. Lee, can you talk about your personal background? How did you get interested in science and perhaps in space in particular?
I mean, in my case, I feel that I was just born this way. I think, because I remember when I was like 5, I was in kindergarten, and I remember this vividly. It was nap time or something, but next to me there was a shelf with some books on it, and one of them was this little, like, encyclopedia that was nothing but just pictures of the planets, real pictures. And I remember looking at Saturn and just looking at it, and I remember having a sense that these were other worlds, and Jupiter was in there too, but I just wanted to look at Saturn. It was so different, and with those rings, like, just so intriguing. So that, I don't think it was just that moment, but that was one of the moments where it was like, there's this whole bigger other aspect of where we are. Where are we? Just kind of one that never went away. It just kind of continued to grow. How about you?
Yeah, that's cool. I was born in Hong Kong, the least astronomy favorable place on the planet, because you're in the tropics and an urban jungle with Chinese neon signs everywhere. I remember the effect of seeing the night sky for the first time, what that did on me. And then I was spending my time as a kid watching sci-fi on TV, Star Trek, Lost in Space, and I was doing very poorly in class. I remember we were 43 kids in this classroom, and I was consistently ranked, because there was ranking at the time, 42nd. That's because the 43rd kid had a learning challenge. So I was put in a boarding school by my parents in France. And so I grew up in a Catholic boarding school. And as a result, I'm not a Catholic, but I also enjoyed some beautiful night skies in France, and was longing to one day come to America to follow my American dream, to me, America was the place was the country that sent people to the moon.
But when you lived in Hong Kong, you actually never saw the stars.
Well, I could have had I, gone out.
But not there in the city.
Hiking around too.
Yeah,
but,
yeah.
I was really leading an urban life at the time, and so not so much, yeah.
Yeah.
I grew up in the countryside, and so we had a lot of sky to look at, especially the sunsets. I would just go out and look over the farm fields, and we had the northern lights that would come out occasionally as well in northern Wisconsin. And but I think I didn't have a backyard telescope or anything, but as a postdoc, I went with a team from Carnegie down to the Atacama Desert, the Yungay region in between. It's like a double rain shadow that just it gets like a centimeter of rain every 100 years or something. And we got there was such a long journey. There were just planes and trains, everything. And finally we got there and it was the middle of the night and we just didn't even look at what we were doing. We just threw our sleeping bags on the ground and laid down because nothing lives there. So it's like not a problem. But I just was so exhausted. I laid down and I opened my eyes and looked at the sky. And I was just like, wow. That was the galactic center was there and just these like spires of dark gas. And it was so real. I felt afraid. I felt a little afraid. It just was so real, that like separation between us here and everything else there became quite close, a little close for comfort. I felt unshielded, but yeah, just that immensity. It was just so visible. I've never encountered a sky like that before or since.
Those raw feelings of awe or of wonder can be fearful. That morphing of the word into awful that comes to mind. Yeah, powerful. Yeah. All right. For either the book or the movie, was there anything that surprised or shocked you?
Yeah, the movie. If you do the math of this time dilation thing in the twin paradox, Ryland Grace doesn't make it back, is not back on Earth. I mean, so the probes he sends back to Earth to deliver the fix to the astrophage problem. By the time they get back to the Earth, basically, something like 30 years have elapsed on the Earth. And so this lady who's in charge of the program is not shown to have aged enough. She just looked like she had a bad weekend, and but really it's 30 years. So it would have been good if they had sort of made her look like a much older person for that final scene.
Right. That's true. I think I was struck again by the musical. So I actually read the book I listened to it.
Yes.
And it's great because when it's time for Rocky to speak, they actually use musical tones in the audiobook. Yeah. And then after a while, they start just translating right away. But it's still with the background of, little musical chords and stuff. And I have to say, like, that was the part of the book where I started really paying attention. Like, it started getting a lot more interesting to me at that point.
Yes. All right. With Comet 2026A1 on April 5th, grazing the sun at less than 500,000 kilometers, isn't that as magic as astrophages, in case it won't evaporate during the encounter?
Can we hear that one again?
Sure, let me try that. With Comet 2026A1, and in parentheses, MAPS, which I think may be a reference to a particular spacecraft. Anyway, with Comet 2026A1 on April 5th grazing the sun at less than 500,000 kilometers, isn't that as magical as astrophages, in case it won't evaporate during the encounter? Not sure I get it. I'm sorry, I
guess we'll see what happens. I mean, there is a family of sun-grazing comets that's pretty spectacular when they, fly by the sun like that. But
and that maybe the point is that this questioner is surprised that they survive in the way that astrophage perhaps is able to survive on the surface of the sun. I guess there's quite.
Well, the comet evolves an atmosphere essentially, of vapors and dust. So that's called a coma, and then it gets blown in its wake by the solar wind and by its own trajectory. So comets are spectacular, and I guess what's interesting to me in particular with comets is that even though they all most of them, the vast majority, are from the solar system, from the outer parts of the solar system. They exhibit quite a bit of diversity in behavior. Some have, stronger signatures in ammonia, others less. It's really interesting. Ultimately, the fate of those that come by the sun regularly will be that they will just, disappear. They'll dissipate. But if they don't dissipate entirely, then they go back to the outer reaches of the solar system, and they'll come back. In this whole business with small bodies grazing the sun, to me, the most fascinating are these recently discovered, or two objects that have come from the outer solar system. I mean, beyond the solar system. Oumuamua and Borisov. Borisov was a comet. Oumuamua was more of an asteroid. And then there's Atlas, of course, this year. So 3 objects now. And you sort of have to think about this, because not only are they coming from beyond the solar system, but they could be much older, for example, in the solar system, or much younger as well. They come from a different star system, so who knows when they were formed? Maybe all the way to the beginning of the history of the galaxy. So these things are not just amazing, interstellar travelers, but they are really, time capsules in their own right.
Yeah. It really brings forward the idea of panspermia as well.
Yeah.
Like there is material being exchanged between the stars, or at least flying through each other's systems.
Yep, exactly.
All right, here's a fun one. Do you believe aliens have already been to Earth and or are here now?
So I have this theory that it's hard enough to get between the stars as a spacefaring or spacefaring aspiring civilization, that the only ones that actually develop that capability are the civilizations that have basically figured out how to work with their inner landscape as well as the outer landscape, that they've managed to become the kind of society that is not on the edge of ripping itself apart all the time. And so it's like a filter, only the ones that make it through that time of development and are relatively peaceful, really, by the time they're traveling between the stars, are the ones that would be here. So we wouldn't have necessarily heard, if they're not out to create waves or disturbances, and are actually, have some care with that, they could be here and we wouldn't know.
Oh, thank you.
But that's my thought about it.
Thank you.
Yeah.
I know you've got a view on this, Dr. Lee, no?
Well, at the SETI Institute, all the research there is underpinned by the Drake equation, named after Frank Drake. And I guess everybody here is familiar with the Drake equation, but it's a very simple formula mathematically. It's a multiplication of 7 terms that would give you, if you knew the value of each term, the number n of advanced civilizations in our galaxy today. Now, I have a personal take on the number n by giving some pretty conservative values to the terms of the Drake equation. And so my view is not necessarily the most popular one at the SETI Institute, because I think n ends up being about 1 per big galaxy like ours. And which means that we might be alone in our galaxy. Now, of course, there's over 100 billion galaxies in the universe, so we're still in good company at the scale of the universe if this were true. But we don't live, I don't think, in a Star Trekian or Star Warsian galaxy where, there are bars where civilizations hang out and play jazz. Now, in Project Hail Mary, therefore, encountering an alien civilization that is so close to ours, I think is really improbable. But again, I could be wrong by orders of magnitude. But having said that, Andy has a twist on this. He actually explains that we actually all came from a common ancestor that evolved from, I forget which planet, which star system in our neighborhood. And so genetically, we're all connected. So it's still just one tree of life that is connecting us. In other words, we're related genetically to Rocky and to astrophage. And all of this is still, in that sense, the Drake equation doesn't quite apply because you're not talking about a separate genesis of life. You're talking about, us or some common ancestor that essentially spread. Anywho.
This reminds me of another thing about that book that disturbed me a little bit, which is, you know how sometimes an invasive species will come to a continent and then the DNR has a good idea to introduce its predator into the environment as well to control that. And then its predator decides to do something completely different and create a whole nother situation. I was thinking about that with astrophage and its predator and bringing the tau amoeba.
Tau amoeba,
here.
yeah.
I was just like, this is a lesson we definitely would have learned, right? Like planetary protection would not be cool with that solution.
Yeah.
I mean, maybe we're at our wits' end, so we just have to. But I'm just like, guarantee you, tau amoeba is not going after astrophage when it gets here. It's going to find all kinds of other things to eat.
It's going to find humans a lot more
Right?
delicious.
Suddenly humans are the main thing that it's going for. And it can apparently tunnel right through solid xenon. So,
exactly.
there's no way to contain it.
A SETI consideration that's almost as well known as the Drake equation is the issue of the Fermi paradox or Fermi question. Because this question asks, why have aliens not found us so far? Will we cease to exist because we find alien life? Well, let's just go with the first one. Why have aliens not found us so far?
Well, Carl Sagan used to say, jokingly, I think, that the best proof that there's alien intelligence out there is that they haven't tried to contact us. But joke aside, if n, the number of advanced civilizations, turns out to be actually a really small number, then there's no paradox. I mean, the paradox comes from the fact that if n is a large number, if there are many civilizations out there, how come we haven't somehow detected them by now? And the answer is, well, maybe there's no paradox if n is small to begin with. But of course, if n is actually big, well then either we've still been too low-key. We might be able to be detected optically in our atmosphere, analyzed as being oxygen-rich and therefore being a planet with life from very far away now, millions of light years away. But on the other hand, in terms of us being detectable as an intelligent civilization, as an advanced civilization transmitting radio waves, I mean, we haven't transmitted radio waves in a powerful ways until the 1930s, so about a century. So we would be known only about 100 light years away as a noisy radio source that's intelligent, or maybe not that intelligent, really. Yeah.
Yeah, and I feel like there's a number of answers to that. I mean, one is that we're at about n equals 1, so even if there is another one, they're really far away. Or it could be that we are at the level of development that's still fairly insignificant, in the cosmic community or the galactic community. I like the zoo hypothesis. There was an American or Astrophysical Journal article many years ago published, the zoo hypothesis. And I always had that. I had that abstract cut out and on my office door throughout grad school saying that we have been set aside as a wilderness area or zoo. And Or, you could have, just, that civilizations who figure this out, they know like who to disturb and who not to disturb, or, or they're here and we don't really know, It could be, the question sort of assumes that we know this, like we know for sure that they're not here, and we would know if they were here. And that assumption isn't obvious to me at all.
Yeah. Yeah, and of course we've been technological since, a very short time, and this makes me always wonder, what would a civilization that somehow has a head start compared to ours of only 10,000 years, say, or let alone 1 million years. They might have ways of traveling and, found passages through wormholes to really come from far away, even if they are sparse in our galaxy. So I think we should be open to the idea that we conceivably could have been visited before, but there's no evidence for that. And, that goes also back to what Carl Sagan used to say, extraordinary claims require extraordinary evidence. And so there's nothing that I've seen in claims of aliens visiting us that screams, hey, this has to be an alien civilization visiting us, as opposed to humans being clever.
Mm-hmm.
And I take it the SETI Institute would let the cat out of the bag if there were bodies at Area 51 of evidence of alien.
Like somebody would.
Yes.
That would be
Yes.
hard to keep a lid on something like that.
This page intentionally left blank.
This questioner has a query regarding the idea of panspermia. Is there a way for that to be possible between stars, or maybe just within a solar system?
I mean, these interstellar asteroids, right? These interstellar asteroids that have come visit us, maybe they are an ejecta fragment from some giant impact in another star system. So if that planet where the impact took place had life, the object could have left that planet with, some life forms on board. But then you have the issue of would they have survived in deep space, being zapped by radiation, and neutrinos over time. Neutrinos will interact with you given enough time. Will that life form be preserved properly? So, it's a big challenge to see how panspermia could really work in reality, given the radiation environment that we have in our galaxy and between stars, and the time it takes to travel. But it's still, I would love to actually get a mission going to check out one of these interstellar interlopers, sample them,
Amazing. That would be amazing.
bring back the samples, and go from there.
Well, isn't there an object in the Kuiper Belt that's thought to be of origin from a different star, like an
Oh, really?
object
I
that's
didn't know.
actually bound to the
didn't know.
sun? I'll have to follow up on
okay.
that. But yeah, that would be really interesting to look at. So we're talking about millions of years of travel time between stars, even for the nearest
Yeah.
ones, right, at these velocities. Yeah, it is hard to imagine that. We got some pretty hardy little organisms on Earth that have been exposed to a lot of stuff, and like water bears. Oh my goodness,
Yeah.
with such cool little creatures, but still 1 million years. That's tough.
We have time for just one more question. So this is another one that I think you'll find fun. Of all the alien depictions in movies, or all the depictions of aliens in movies, which Hollywood alien is your favorite, and why?
I need a second to think about this.
I like Predator.
Predator was pretty great.
Predators are really ugly by all standards, but they are amazing creatures, and they hunt us as game. So I think there's something to be humble about.
loved that movie. That was like one of my favorite movies of all time.
Oh, thank you for the encouragement here.
You know, honestly, I think maybe because it's just so fresh in my mind, I loved the movie Bugonia. I don't know if people have seen it. I loved it. And that was cool because, you know, the whole movie, I did not think that. I thought these people were just nuts, right? And then she gets up there and she's like, we couldn't communicate with you without our hair. And I was like, wow. It was hilarious. I think that's my favorite the alien civilization right now.
I have not seen Bugonia, but now it is on my list.
Highly
Thank you.
recommend it. Highly recommend it.
I'm going to take the liberty of answering this one. Mine is still Mr. Spock, and I'm only half alien, but boy, every time I see somebody split the hands, I say, I get chills inside. Still a good feeling.
Yeah.
Our thanks to Dr. Maggie Turnbull and Dr. Pascal Lee from the SETI Institute, both of them. I'm Tucker Hyatt, and on behalf of the Commonwealth Club, Wonderfest, and the SETI Institute, I thank you for coming tonight. Amazing, amaze, amaze, amaze.
Amazing.
Great ending.